by R. For number 1, your domain, since you just talked about that, you could write it in either interval notation or set builder notation. X is greater than or equal to 2, or from 2 with a square bracket to infinity. Hopefully that starts to make more sense now that we've actually done domain and range. Questions on number 1? Okay. That would be great. For number 2, Josh, Rashad, I cannot talk over you guys today. For number 2, which points are solutions to the inequality? Is this the first one, -2, 4? Would be your answer. Number 3, you're combining like terms. Distribute, so you get -12x minus 6, minus 2x plus 6, plus 15x minus 20. Combine all of your like terms, you get x minus 20. Plus. Questions on those 3? Number 4 is asking, is this graph a function? The answer is yes. It passes the vertical line test. For number 5, you would need to find the equation of this line by having the slope y2 minus y1 over x2 minus x1. You get -2. Then pick a set of points, use that in your y minus y1 equals m times x minus x1 formula to get the equation of y equals -2x plus 4. You could have also graphed those points, found the slope and y-intercept like that. Questions on those 2? Alright. So take out your notes from last class if you haven't already. We're going to continue those. For the remaining parts, you shouldn't need your calculator, but if you wanted to check yourself, you can use that. Are you gonna? Do you need a pass or anything? You're leaving, right? Have a good weekend. See you on Monday. Alright, let me get everyone's attention back up here. Okay, so last class we talked about different transformations and how they work and how they apply to the parent function. Now we're going to specifically talk about what those words mean and how we can remember them and how we can use that to write different transformations. Those of you that did not pay attention last class, you should probably pay attention to that. So for anything vertical that's applying to your y values, for your horizontal, that's anything to your x values. And there are different vertical and horizontal things. But the main thing we need to know with vertical, with our y values, that they'll be doing something up and down or something vertically, whereas horizontal will be moving left and right. When we talk about vertical things, these are things that happen usually outside of the parent function. So like plus and minus on the outside, those are vertical things. When we have the negative and minus, negative and plus on the inside, those are horizontal things. When we're multiplying on the outside, that's why it's vertical. If we were multiplying on the inside, it would be horizontal. When we flip on the outside, it's a vertical reflection or a reflection over the x-axis, vice versa. With translated, that's your moving. So I'm going to draw two things here. One for vertical and one for horizontal. I'm going to draw in our parent function. You can do the absolute value or the quadratic function. I'm just going to draw a rough sketch of this. For our vertical translation, remember that's another word for just moving or shifting. And so this is either going to move up or down for vertical. And that would be a plus or minus on the outside. How do you know if you up and down? It will say plus or minus. Let me also do this. Write that down too. This is like your vertex form of your quadratic function. If you want to write down the vertex form of your absolute value function, it's very similar. So for vertical translating, you're looking at your plus k or minus k, whatever it says. That will tell you what you're doing if you're moving it up or down. For horizontal, you're moving it left or right. So these are all just rough sketches. It's okay if yours doesn't look like mine or it looks different as ours. What tells us left or right is the inside, so we're looking at that minus h. To see what our value is and if we're shifting left or right. For reflection, we're going to do the same thing, draw two separate axes. And draw our parent function. So reflection is like a flip of some sort if you are looking for words to help you. A vertical reflection is a reflection over your axis. Is here, now it's down here. It flipped over. Whereas the horizontal reflection is a little harder to see. Because it's flipping, it's like turning around. Before we get into stretch and compress, do you have any questions on vertical, horizontal, translated, or reflected? Josh?
For H, does he have a
My drawing is really bad, but it doesn't change really because it's like on the y-axis and it's flipping around. For stretch, we're going to draw again 2 different axes. Stretch and compress, you're still looking for a scale, a certain number, but there's a difference. Thank you. Okay. For the parent function, a vertical stretch, and I just remembered I forgot something for reflected. I'll go back to that in a second. For a vertical stretch, we know that's going to be some whole number, and it makes it get narrower. What it's doing is stretching towards the y-axis. That's why it's a vertical stretch. That's why it's getting narrower, because it's stretching towards the y-axis. I'm going to write that just so you have it. Horizontal stretch, however, does the opposite. It stretches towards the x-axis. It's not a very good representation. We did not do anything with horizontal stretches. That would be something being multiplied on the inside. We're not going to worry about that. There'll be something, those of you moving on to algebra 2, you'll cover that. Before I forget, your value that you're looking for, this would be your A value. And it has to be some number that's bigger than 1. I should say 1. So it has to be some whole number bigger than 1. For horizontal, this would be on the inside right in front of x. But we're not going to worry about that. Then for compress, it's opposite for both. So we're going to draw in 2 more axes and parent functions. Now for a vertical compression, it is shrinking. Shrinking and compressing are the same thing in math. it's shrinking away from the y-axis. So when you draw it, it looks wider. But for horizontal compression, it's shrinking away from the x-axis, so it's going to get narrower because it's going away from the x-axis. With your vertical compression, we talked about how that was a fraction. So I'm going to say this is A is less than 1, or between 0 and 1. It would be a fraction. And then I'm going to quickly go back. If it was reflected, then your A value would equal a negative value. The horizontal, if it was reflected, there would be a negative on the inside. So when we actually write out, or I'm sorry, we're not writing out the transformations now. We're going to be given transformations, and we have to put those transformations where they're supposed to be in the function form. Before we do that, what questions do we have on any of this? A lot of this was just like summarizing all the stuff we did last class. Number 1, x squared is translated 4 units down and 2 units to the right. We have to think about 4 units down. Is that an inside? Is that an outside? What would that look like? 2 units to the right. Is that an inside? Is that an outside? What would that look like? 4 units down. Would it be inside or outside? Say that again. Your vertical outside. Your also vertical left and right. Vertical outside. If it's moving down. So I should say this. Is down vertical or horizontal? Or is it vertical? That means by default that it's outside. If we were to translate 4 units down, how would we write that? Just the down part. Just the down part.
This one?
We haven't gotten that far yet. If I was just moving something down forward, how would I write that? Okay, look back at your previous examples. How did we move something down? Yeah. So that would be a -4. I don't know. Then we know we're going to be doing 2 units to the right. Would that be horizontal or vertical? Horizontal, so that means that would be on the inside. After this problem. So because this is on the inside, we now need to think about how would we write 2 units to the right? Oh, it'd be the opposite. Minus 2. So now that we know those two things, then we can take them and put it together with our functions. So we're going to start off f of x equals anything on the inside needs to go inside parentheses with x. So this is going to be x minus 2 squared. And then we're going to take that number on the outside that we need.
So how do you?
It does the opposite. So on the things we were doing before, anytime you had a plus, it really moved to the left. Anytime you had a minus, it really moved to the right. It's opposite. Think about it like your horizontal things don't do what they're supposed to do. So they do the opposite. Okay. Other questions on that? If you get through these 4, then I'll give you some practice, and it's not a lot, and then we'll have other time. So for this next one, x squared is reflected over the x-axis. So we need to figure out if that's a vertical or a horizontal. It's reflected over the x-axis. Would that be? Yeah. So because that's vertical, that's going to be on the outside. Translate it 7 units to the left. Would that be inside or outside? Inside. The reflected over the x-axis is just going to be a negative. So you can write that if you want. Translated 7 units to the left. How would you write that number? Positive 7. Taking our function and putting those two things in it, we have f of x equals, we need the negative on the outside. We do have something on the inside, that plus 7, so we're going to need parentheses, and then x plus 7. What questions do we have so far? The reflected over the x-axis. That a value on the outside.
So.
Right now, this value is 1. And number 1 is 1. Unless it says, like in the next one, it will change. Usually it's this one. It also depends on what's given. So like this one was not 1. But this was -1, this was 1/2, this was 1. It just depends on what's on the outside. Before we do 3 and 4, these words got switched. This should be stretch, and this should be compress. now, if this is stretched vertically, well, that tells us that it's being stretched vertically, so it's going to be on the outside. By a scale of 4. That means that number they give us, we're going to multiply that on the outside. And then reflected over the y-axis. Would that be a horizontal or vertical thing? If it was over the x-axis, that would be vertical. So this is horizontal, so this would be inside. Because that is inside, we're going to have a negative inside parentheses or something like that. So now, looking at our things, we have f of x equals the number on the outside, we have that 4 times the absolute value. On the inside, we need this reflection, that negative, and then just x. And that would be it. There's a little less to write with absolute value functions than quadratic functions. No, it was reflected, which means it's negative. It was on the inside because it's reflected on the y-axis. It was a horizontal. For the next one, it's compressed vertically, so they're telling us it's vertically compressed, so that's going to be on the outside. We're going to multiply it by that scale factor, and then it's being translated up 14 units. Up would be outside or inside? Is it vertical or horizontal? Vertical. And vertical is outside or inside? Outside. So what that means, if there are two outside things, you're not going to have like parentheses or anything like that. So this would look like f of x equals, you need this number on the outside, the 1/2, times the absolute value of x, nothing inside, and up 14, how would we write that? How would you write up 14? Right. Wait, yeah, 1 second. So I'm going to pass out practice for you to keep trying this. Let me find that. So when you get this, it'll only be numbers 9 through 13, but hold on to this because you'll need it for later.
You said 9 through 13.
If you do 9 through 13, we'll go over that towards the end of class. That is all I need from you today. have your priorities right. So again, number 9 was already given to you, but I'll talk through that. X squared translated 2 units to the right. This is going to be on the inside. To the right is going to be minus 2, which is why it was minus 2 inside parentheses. Make sure this is squared. X squared translated 6 units down. Down is a vertical thing, so that would be outside. And because we're going down, that would be minus 6. Our function, you can use f of x or y, doesn't matter, they're the same thing. Y, that's fine. If you put f of x, that's fine. You don't have to change it. Y equals x squared minus 6. No parentheses. I mean, let me say this. You could have parentheses here, but that wouldn't change anything. Parentheses are for x squared. If it was an absolute value, you usually don't have parentheses. It's just inside the absolute value bars. Any other questions on the 10? $11. X squared translated 4 units to the left, that is inside. And it would be opposite, so it would be plus 4. So y equals, in parentheses, x plus 4. And then make sure you are still squaring this. Questions on that one? X squared translated down 2 units is outside. And that would be a minus 2. Reflected across the x-axis is also outside. And that reflection means you're going to have a negative. So when you write this, you would have y equals negative x squared minus 2. Questions on that one? The last one, x squared translated 3 units to the right, so that's inside. But opposite, so minus 3. Reflected across the x-axis is still outside. So we would have y equals our negative on the outside, but we have something on the inside, x minus 3, all being squared. That's on that one. So, on this lesson in general, there are no Khan Academies for this one, just Delta Math. So I would say practice that. That Delta Math is due next class. Yes. And then next week, if you are missing tests on Tuesday when you come in, that's what you're working on. If you need to work on benchmark work, you are working on that if you're not missing tests. If you want to get that done ahead of time, so if you are wanting to retake, I would say come see me after school on Monday, that we have more time in class on Tuesday to work more on benchmark work